What's up guys, and welcome to the fourth part in my stress testing tutorials. So in the previous tutorial we started looking at how load test works and the basic settings that you can use. And now we're going to continue with testing out different environments. So what I've done here is that I've set up a configuration on I'm using a PHP backend, by the way. It's a Lumen framework that is built on Laravel, and what I got here is simply a ping endpoint that returns a hard-coded text string POM. So whenever you test it out in Postman, just get a response right here. And for serving this, I'm using simply PHP. So the PHP built-in web server, which is a pretty basic server, I would say. It's not really anything fancy. So you can see here I use PHP this version, and then I just serve on my address. For some reason, load test didn't like when I had localhost here, so I had to put my IP address for some reason. I'm not sure why. This might not be the case for you, obviously. So let's just start by trying it out in the terminal, see what it gives us. So I have this ping endpoint, as you remember. So let's see what it gives us. And you can see immediately down here in the background it starts processing the requests. And you can see that it's not really effective. It can take about 15 requests per second, which is really not a lot. Maybe a little bit more, like 17 even perhaps, before it starts dropping out. And okay, so I'm gonna go ahead and stop this because otherwise it'll run further. So I'm gonna set n, which is like the number of requests, and I'm gonna set it to 100. So it's gonna make 100 requests, and I'm gonna set the RPS to something higher than 16. So I'm gonna set it to 20, and so this shouldn't be able to work, because we know that it can handle about 16 requests. So now we're going to look at what happens when you try to push it a little bit further and see if we can force it to throw some errors. It might work. And yep, as you can see, now that I've specified the exact number of requests that I want up here, we also get a nice little summary down here, which is kind of nice. So you can also see that it made 100 requests with one concurrency. We're going to go through what that is later. And it did 20 requests per second, and the total time it took. And here, this was actually what's nice. You can get how many, 100% was within 1.2 seconds. And yeah, the part how many requests were within a certain time range. So what we can do is we can also set the concurrency level, because at this point it's concurrency 1, which means that it's one client that does 100 requests at this speed. So it does 20 requests per second, and it at a maximum of 100 requests, and there's only one client doing it. So let's go ahead and make it like 10 concurrent clients that makes 100 requests. In total, 100 requests at RPS of 20 and see what that gives us. And hopefully we should start getting some errors soon. It still works, so let's try and crank it up even a little bit more. Let's give it like 60. So now you can see the errors start to occur. So even though it first initially gave us, I don't know, 16 RPS, something like that, you can see that we can go a little bit further if you push it like to the limit, but then it's gonna, I mean, the response times here are terrible, obviously, because it's just returning a hard-coded string, and it's just running on the same local machine. So we don't have any particular network latency that we need to take into account here. And it still drops like 2 errors, which is really not good, but I wouldn't say that, I wouldn't go above 50. I think 50 is like, I don't know, let's, because the RPS is kind of like a throughput, and this was only like 10 clients. What about, I don't know, 50 clients? That makes, yeah, let's try this out and see what happens. It should drop even more errors, I think, if my gut tells me right, you know. It was about the same, but still, it's not really any good response times. And you can also see down here that it hasn't served every request yet, and that's why it's still waiting. So now it's done, so we don't have any HTTP packets hanging around the network. So let's try another approach. I've also set up Apache on my MAMP. So I have Apache server running, and it's running on port, I think it was port 8888. This one, I think. So let's see what that same setup gives us, but with Apache instead. So you can see we get so much better response times here. And I should also mention that the configuration for Apache is nothing fancy. It's the default settings for everything. So this is no problem whatsoever. I mean, sure, there was some crappy latency, but I would still say that this is fine. So let's give it like 100 client that does 100 requests. So they make one request each, I think, to 500 RPS. Okay, and then it starts dropping errors. And you can also get a little bit better throughput. So as you can see, you have to like fiddle around a lot with it in order to kind of get a feeling of the responses that you can use. And I'm gonna make a quick comparison of these servers, so we have something that is comparable, basically. So I'm gonna go ahead and just use this. I'm not gonna use the RPS, and I'm gonna start with this and see what it gives us. Okay, so we get 34 RPS, and the response times were, I mean, not good, obviously, but still not terrible. So I'm gonna go ahead and crank it up a little bit more. All right, so let's give it 1,000. This shouldn't work, I think. Okay, that definitely didn't work, so let's lower it a little bit. Let's try, I don't know, 400 maybe? Oops, I accidentally gave it 4,000. It wouldn't actually mean any more stress on the API, it would just mean that it will take longer time for it to finish. Okay, so it still doesn't like it. You can see it start dropping errors, and I would say that we're pretty close to what you can deal with. So maybe 200. All right, so somewhere between 200 and 400 is okay. So maybe 300. All right, so I would say somewhere around 300 requests is fine. It's like the request per second is about this. Now let's try this out for comparison with the server, the standard PHP web server, and see how that will deal with the same amount of traffic. So if you remember, we had about 10 seconds in the worst case. So as you can see here, it doesn't scale as good, and you see all the requests here not actually being properly handled. But this doesn't have a, like, the throughput here is so much worse, and also you can see that in the response times that we have about 20 seconds of response times. I think after like 30 seconds, some clients will start to close the connections. I think the default in a browser is like 1.5 minutes, but I mean everything above 5 seconds is so crappy. So let's compare this with another application that I have on another computer on my network. So this is actually not on the same computer, it's on a different computer. And the difference between these are that the other application that I have on the .7 port 3000 is a Node.js application, and it'll be interesting to compare them. So as you can see, there was a big difference here. And then I should also mention they are not on the same computer. The applications that I previously tested were on the actual same physical computer. So yeah, you can see we get so much better response times. So we had about 10 seconds with Apache on the PHP application. Here we have like half a second with the same amount, and the throughput is like 252, which is so much better. And it's an Express application. It looks let me see where I have it. It looks something like this. So it's just like Hello World application. And let's see how far this will take us. All right, that was maybe a little bit too much. But still it handled. There were some errors, sure, but it still responded to most of them. There was 1,000 requests, so every 10th request resulted in an error, so it was too much. But the response time is still there. It's still below 12 seconds that we got. If you remember, we got like 12.5 seconds on the standard PHP server that we have here on port 8000. So it's still better, you know. And one thing that I should also mention right now before the flame wars of the framework starts is that this is only a hint of what it can do. You shouldn't take these numbers, so you shouldn't take this like 100% truth, because it's just a heads up. Basically, it's just like, does it scale good? Which one is faster than the other? Kind of like that. It's not like you can depend on this exact amount of timing every time. And I did this because you can see the comparison about that it actually matters what kind of server you have running, you know. Node.js is super fast with serving HTTP requests. It's the fastest that I know of at this moment. Maybe there is some obscure setting with C++ or something like that. I don't know, some socket programming that can be even faster. But generally speaking, when it comes to the big frameworks, Node.js is probably the best of serving this kind of data we're testing for here, like JSON data. But when it comes to file serving, it's really sucky. Then you should use Nginx instead. And when it comes to PHP application, I'm not an expert on this, but I would say probably Nginx also, or Apache. So this was just an introductory to get a hint of what we're gonna do in the coming tutorials. So I hope you guys liked it, and don't forget to subscribe and like put a comment if anything is unclear, and I hope you liked it, and I'll see you in the next tutorial.